Okay, so today's lecture number 10. And today's the 15th of March. Yeah, so there's one question in the web assign that is a bit strange, and I agree. Uh I think it's a bit weird in the way it's explained, so I'm just gonna tell you what to do for that one. Um Let me just pull it up really quick. So this is from homework number 5. And it's one of those quadratic modeling questions. So you have like a scenario. This is number 8. So number 8 has something about a square fence. I mean a rectangular fence, right? It has 2,400 feet. That's 2,400 feet of fencing. And what they give us is they give us like we have a river of some sort or like a river bank. And then we have a rectangular field around here, right? And then it says this is A and this is X. And then it says you want to find the dimensions of such a field that's drawn this way. So the fence, of course, the fence is built not not along the border of the area and the river, but instead it's around here. It's on the other edges. So this is going to be my fence, right? And then part A asks a very strange question. No, you will not have a question like this. I did not put a question like this on the quiz, so don't worry about that for the quiz, but for the homework, yes. And most likely for the exam, yes. It says experiment with the problem by drawing several, calculate the area, and use your results to estimate the dimensions of the largest field. Answer your answers as a comma separated list. So, yeah. Um, part A. So for part A, guys, just use answers from part C. And write in a comma separated list for part A. Because if you get to do part C, part A is just like they're trying to make it like an open-ended question. Um, it's kind of to me it's also a bit redundant. So once you get part C, those values for part C are is the answer for part A. Like I said, they're just trying to make it more open-ended in part A and make you experiment with the problem and make you draw different. That's That's not necessary if you don't want to go through that. I'm just giving you the more like the straight cut uh, answer. What's more important is being able to find out what are the dimensions that maximize the area. That's more important. So if you could do that, then we're talking. So part B is really the core of this problem, right? Part B. Part B is asking, what is the function that models the area? Now that's the key here. So for again, what's the area of a rectangle? The area, it's quite simple, right? It's length times width. Length times width. So we know the width, right? We know the width. So let me just put this as a dot. We know the width is what? Isn't it x? So similarly, this is also x, correct? But what is the length? What is my length? Does anybody know how we can figure out the length? And the way we want to express the length is we want to express it as a as an expression in terms of x. So does anyone have an idea of how we're going to express the length as an expression in terms of x? So the key here, guys, the key here is this. There's 2,400 feet of fencing. So suppose I didn't know what the length was, right? So I'm gonna call this another variable, correct? So, but what do I knew? What do I do know? I do know is that the perimeter of this field, which is only 3 sides covered by fencing, is that it's going to equal what? 2x plus y, which equals what? 2,400. And that's pretty important because from there, what can I figure out? I can figure out if I subtract 2x on both sides, I can figure out the 2,400 minus 2x, that is y. Y, the length, can be written as 2,400 minus twice the width, which is x. So I can say now that this guy here is really what? Is 2,400 minus 2x. And now I can replace it here. So this is 2,400 minus 2x. And if I multiply that by x, that gives me my area. And that's a of x. And of course, we can write this as an area, a function in terms of x. And this is what I'm after. So that would be part B. And I'll let you guys do part C, because from here, what do we get? What do we get? We get 2,400 minus 2x, 2,400x minus 2x squared. And this is what kind of function? This is a quadratic. This is a quadratic function. And from there, we know what? We know this has a leading coefficient of as a negative. It's a -2, so it's going to be pointing downward, opening downward, but having a maximum point. And so we can figure out the maximum point. So then at this point here, for part C, the smaller dimension and the larger dimension are really just find the vertex of a quadratic function found in part B. And so whatever you get for part C, like I said again, for just for the sake of WebAssign, you plug that in for part A. But in part A, you would say in part A you would say the smaller dimension, whatever that one is, comma the larger dimension. So that's how they want the yeah. So you want the larger dimension as a second. So that would be the answer. That's how you plug in the answer for part A. So again, I'm not doing the whole thing because I think from here, I think you guys should be able to find the vertex. And then once you have the vertex, then you have part C, the answer for part C, and then you can just plug that in for part A. Okay? Does that make sense? Again, the hardest part, like I said, the hardest part of a problem such as this is this portion here, is the actual finding the function itself. That's the hardest part. And there's a lot of, we have to be able to easily go from one variable to the other and stick with only finding a way to express all of our dimensions in one variable. If we're able to do that, then we can create a function that only has one variable in it, and then we can go from there. All right. So any other questions about this portion of the homework? So that's number 8. Anything else? No? All right. Okay. So let's continue now with so we've done polynomials last time, right? We talked about graphing them. We talked about how we name them, the degree, all these different terminologies that come with polynomial, the leading term, the leading coefficient, the end behavior, right? The y-intercept, the x-intercept. And we talked about multiplicities last time. So multiplicities, whether it's odd or even, tell you how the graph is going to either go through the zeros, which are the x-intercepts, or they're going to bounce back from the point that's on the x-intercept. So that's what we talked about last time. And now, if you guys look at the worksheet or the PDF, we're going to continue on with polynomial functions. In particular, we're going to talk about the division of polynomials. So yes. So here, so he has something that's called the division algorithm. This looks complicated, but it's something that you all have seen. So what I like to do sometimes is to explain this, I use a very simple, extremely simple example. So for example, just to like get our feet wet here. So recall long division, right? And you probably looked at this maybe in elementary school, maybe most likely in middle school. When you do 17 divided by 3, for example, right? So I can write this as 17 divided by 3 like this, or 17 over 3. They mean the same thing. Now, the thing is, what do we put after this? Like, what do we put? How do we express the answer? So what do? Don't we take 3 and make it and ask ourselves how many times does 3 go into 17 first? And then we say, oh, 5, if we take 3 and multiply 5 times, that's gonna, get us really close to 17 without going over 17. And then what's the next step? We do 5 times 3 and we get what? We get 15. Subtract, right? And when we subtract, 17 minus 15 is what? 2. And then what do we say about 2? 2 is now a what? 2 is called the remainder, correct? That's right. And then what is 5? 5 is called the Anybody? What is 5 here in this? Yep, that's right, Jen. It's the quotient. The quotient. What does 3 represent? The 3 represents the divisor. And then what does 17 represent? 17 represents the dividend. Okay, so this is important. Why is it important? Because in a way, when we divide anything, we're really trying to answer a multiplication. We can interpret it as a multiplication problem. We can say the following. We can say that 17, if you unpack these numbers, 3, 5, and 2, 17 is really what? Isn't 17 3 times 5 plus 2? Isn't this another way to interpret division? We're asking ourselves, what do we multiply 3? And then what's the remainder that's needed in order to equal 17? Now, this is one way that normally people don't really explain it, right? No one says, hey, 17 is 3 times 5 plus 2. But then you realize, yeah, it is. 3 times 5 is 15 plus 2, which is exactly what you did without even thinking. You're really saying 3 times 5 is close to 17, and I need another extra 2 to get to 17. Okay, so now that once we see that, what's the bigger picture? The bigger picture is not that 17 equals 3 times 5 plus 2. The bigger picture is that 17 was the dividend. And the result was that it's the divisor times the quotient plus the remainder. That is the bigger idea. Now, this is called the division algorithm. And we can refer to it as the version 1 because there's 2 versions. But if you have version 1, you can get version 2, and you see how we get to the version 2. And the cool thing is that this division algorithm is not just applicable to numbers. The division algorithm can also be applied to polynomials. And so now we have this. Now we have this version here, which is literally exactly the same. It's exactly the same as the one described above. The only emphasis now is that the p of x, right? The p of x is the polynomial. It's a dividend still, but it's a polynomial. D of x can also be a polynomial. Q of x is a polynomial quotient, and R of x could be also polynomial, the remainder. And the important thing here is that the degree of the remainder, whatever the degree is of the remainder, it's always going to be less than, so I should stress that, the degree of the remainder is less than the degree of the divisor. Let's just keep in mind when we do the division that the remainder will always have a smaller degree than the divisor, no matter what. Okay, and let me finish off this little example. So we know, for example, that 17 is 3 times 5 plus 2, correct? But remember, at the end of the day, what are we looking for? We're looking for what? 17 divided by 3. So how does this help us now? How does this here, 17 equals 3 times 5 plus 2, how does that give us 17 over 3? Well, look what I can do. Can't I divide all of this by 3? The 3's cancel, and look at the result. What's my result? It's 5 plus 2 over 3. Or 5 and 2/3. That's the mixed numeral version. But again, what's the important part here? The important part here is that, and that's where version number 2 comes into play. This happens to be what? The quotient. This is what? The remainder. This is what? The divisor. And then what is this? The dividend. And this is the divisor. So if I divide everything here by the divisor, what do I get as a result? I get this formula version here. I get that when you take P of X is the dividend. So this is basically the same thing as the above. D of X is what? The divisor. Q of X is what? The quotient. And what is R of X? The remainder. Okay, so these essentially are the same thing. It's just that one is expressing another version. One of them is really just multiplication and addition. The other one, there's a division idea here, right? And we're adding by the remainder over the divisor to the quotient. But again, if you guys notice, they come from the same, they're essentially the same, just written differently. Okay, so that's the division algorithm. Every time we divide, we get one of these, we envision the result as in one of these perspectives, either version 1 or version 2. Okay, so any questions about the division algorithm? If not, let's look at the next page. Okay, so here we have a division of two polynomials. We have, again, P of X is going to be representing the dividend. And D of X is going to be representing the divisor. So we're going to perform long division. So what does long division entail? It takes 2x plus 1 and puts it on the outside of the division sign. And this is going to be 4x cubed. Now, I'm just going to include a few one term, plus 0x squared plus 7x plus 9. So you always have to be mindful of the terms that are not seen in the dividend, such as the x squared term, and it's just like a placeholder. So we know that that's not there. That's how we put that 0 in underneath. And does anybody remember how we proceed with this? What are the steps here for polynomial long division? Does anybody remember?
You do 2x into 4x cubed.
That's right. And what do you get?
That'll be 2x squared.
2x squared. So the idea is what again? We look at 2x and see how many times it goes into 4x cubed, or we can divide 4x cubed by 2x. And then we find that the result is 2x squared. So if I were to multiply 2x squared with 2x, I get 4x cubed. And now recall how we did the exact same thing for this simple example, right? What do? We took the quotient, we took this number here, right? And what do? We multiplied it to 3. We're going to do the exact same thing here, except that now they're polynomials. We're going to multiply 2x squared, and we're going to multiply it to this entire divisor. And when I do so, what do I get? I get 4x cubed, and then I get plus 2x squared, right? So again, this comes from 2x squared multiplied by 2x plus 1. That's what it comes from. And then what do I do after this? So I did it. You're right. You subtract. So please, guys, please be careful with this step. This step is a little bit tricky for some because when you subtract a polynomial, what happens? When you subtract this polynomial, you distribute this -1 to every term. So this -1 now makes the positive 4x cubed, it makes it a negative. So I'm just going to put this as just to show you that the signs change. And this positive 2x squared results in a minus sign. And then look what happens. When we combine the like terms on the top polynomial with the bottom polynomial, what happens with the 4x cubed? They cancel. And now look, if we wouldn't have written this, I know there will be some students that will take 7x and then combine it with the 2 because they see it right above. But you see here, it's a little bit easier to keep that in mind. So now this becomes what? -2x squared. And then we bring down the 7, so it's plus 7x. And now we ask ourselves the same exact question. 2x, what do I multiply 2x to give me -2x squared? So we're always looking at the first term for each polynomial that we get. And then we notice 2x to multiply to -2x squared would need a what? A negative x, a negative x. That's it. So if I multiply -x by 2x, I get -2x squared. Obviously, that's what I'm trying to do. I'm trying to eliminate the first term of a polynomial. But now I have to be careful though. -x multiplied by 2x plus 1. What does that result in? That results in -2x squared, and then it's going to be a negative x. But keep in mind that you're subtracting. You're subtracting. And when I subtract by a polynomial, the second polynomial switches the sign. So this becomes what? This becomes a plus. This becomes a plus. And now you can eliminate the first term. 2x squared and the -2x squared with the positive 2x squared cancels. And this becomes 7x plus x, which is 8x. And you bring down the 9. Do you see we're almost there? And we ask ourselves again. So the reason why we keep going, the reason why we don't stop yet is because when we stop, whenever the degree of what's left, if the degree of this polynomial would be less than the degree of the divisor. But if you notice, both of them have the same degree of 1. So I can repeat the process once more. So then now the 2x goes into 8x how many times? 4 times. And then what do? I do 4 times 2x plus 1. And what's the result of that? It's 8x plus 4. Of course, I am subtracting again, right? I'm subtracting. But when I subtract again, what do I do with the minus sign? I distribute the minus sign. And now what happens? 8x minus 8x cancels. 9 minus 4 is what? 5. And the result here, 5, has a degree less than the degree of the divisor. And now what do I say? This is my remainder. This here is my quotient. And this here is my divisor. And last one here. This one here is my dividend. So see, we've completed polynomial long division. And then this p of x, d of x, q of x is exactly what I just written out. So P of x here obviously is what we're given, 4x cubed plus 7x plus 9. D of x is what? 2x plus 1. Q of x is what? 2x squared minus x plus 4. And R of x here is 5. Okay, so again, I just labeled what the dividend, divisor, quotient, and the remainder are. And now we want to write the two different versions of the division algorithm. So remember the first version. What's the first version? The first version is P of x is equal to D of x times Q of x plus R of x. That's the first version. So I just have to write this out as in this form. So I got 4x cubed plus 7x plus 9. What is this equal to? This equals 2x plus 1 multiplied by 2x squared minus x plus 4 plus 5. That's it. That's it. That's the division algorithm, version 1. And then we have version 2. Version 2 is the one that we actually normally write it as because it's the division. It's the division version. So it's 4x cubed plus 7x plus 9 divided by 2x plus 1. What's the result? The result is the quotient, which is 2x squared minus x plus 4 plus the remainder over the divisor, 2x plus 1. So this is the other version or the other way to represent the division. Okay, and that's how we take care of polynomial long division. So any questions about this? Any questions about the division algorithm, how we identify the divisor, the quotient, the remainder, how to perform polynomial long division? Everything okay so far? Have we all seen this, something like this before? Polynomial long division? Is this not new, right? Okay. Okay, good. Good, good, good. All right, so we're going to do the same exact thing now for this example here. As you can tell, the powers or the degrees of the polynomials are a bit higher. So this polynomial long division process works for any kind of polynomial. It works for any kind. So let's go about our business here. So x squared plus 4, that's my divisor. And then we got 2x to the fourth minus x cubed plus 9x squared. Okay. And again, we're going to ask ourselves, x squared and 2x to the fourth. What multiplies to x squared to get 2x to the fourth? And that's going to be 2x squared. And again, what we're going to do, we're going to multiply 2x squared with x squared plus 4. And what does this become? This becomes 2x to the fourth plus 4x squared. Pardon me, 8x squared. And of course, what we're doing here is we're subtracting. But again, when you subtract by a polynomial, you distribute that negative sign, which changes the signs of everything in the second polynomial. The 2x to the fourth, they cancel. Be careful here. Minus x cubed cannot combine with this. So it just becomes minus x cubed. And then we see we can combine the 9x with the minus 8x squared. And so this becomes plus x squared. And then we repeat the process again. We look at the first term of the divisor, x squared, and ask ourselves, How many times does it need to be multiplied? Or what does it need to be multiplied to get negative x cubed? And so you would need minus x. So this would be minus x multiplied by x squared plus 4. And what does that result in? That results in negative x cubed minus 4x. Subtract that. And of course, when we subtract by a polynomial, we're going to do the same exact thing. We're going to distribute. And when we distribute, what happens is all the minus signs inside become a plus. And now when you combine the first terms, they cancel. And I'm left with x squared plus 4x. And then I'm going to ask myself, what multiplies x squared to get x squared, because they still have the same the degree. And of course, it's just a 1. So then I get x squared plus 4. And I am subtracting this from the above polynomial. But of course, when you subtract again, you distribute that negative sign and you get minus x squared minus 4. And when you combine, the x squareds cancel. And when you are left with the result, you get 4x minus 4. And I stop the whole division process. Why? Because what's the degree here? The degree is uno. And the degree of the divisor is what? 2. So the moment that you get something in your division process where the polynomial is of lesser degree than the degree of the divisor, you stop the whole process. I cannot find a polynomial term that would multiply x squared to give me 4x. The only way that's possible is if I multiply by a 1 over x to lower the degree, right? To lower the x squared into x. But if I have a 1 over x, this is not even a polynomial, as we discussed last time. So we can't even do that. So here we go. We found everything, right? We've completed the division, long polynomial long division, and we notice what are our different parts of the division algorithm. So we know for a fact that this is my divisor. We know for a fact that this is my dividend. We know for a fact that this is my my quotient. And we know for a fact that this is my remainder. So now I can write this. P of x is what? P of x is 2x to the 4th minus x cubed plus 9x squared. The divisor is x squared plus 4. The quotient is 2x squared minus x plus 1. And the remainder is 4x minus 4.
Professor, I'm confused about how the equation went from negative 2x to the 4th minus 8x squared to negative x to the 3rd to plus x squared.
Oh, so about this portion right here?
Yeah,
right?
Yeah, that part.
Okay, so we're beginning the first step here, right? The first step is to figure out what multiplies to x squared to 2x to the 4th. And do you agree that's 2x squared?
Yeah.
Okay, so then what's the next step? We take this 2x squared term and we multiply it to the divisor, x squared plus 4. And when you distribute, right? When you distribute this, what do you get? You get, so let me undo this. What do you get?
2x to the 4th plus, I mean, minus 2x to the 4th minus 8x to the 2nd.
So when you multiply 2x squared straight up to x squared plus 4, they're all positive, right?
Yeah.
Yeah. So you get 2x positive to the 4th plus positive, right? 8x squared. Now, what makes it negative is the step right after this, which is what? We take this and we subtract it from the polynomial above. So in reality, we have polynomial minus polynomial. And if you remember, when you subtract by a polynomial, the second polynomial is the one in which that negative sign or that -1 is distributed to every term in the second polynomial. So if all of them were positive, you always have to switch the sign when you distribute that negative. So that's why I do this. That's why I take down the parentheses, and then I say this becomes now a minus. This becomes a minus because you're subtracting. And then therefore, now that you can combine those two polynomials, the first term, 2x to the fourth, that cancels with the minus 2x to the fourth in the second polynomial.
Mhm.
And then you want to continue, right? You want to negative x cubed, you want to combine it with something here, but you can't because it's just x cubed. So we just bring it along. We bring it along. That's the result. And then you say 9x squared. Well, that combines to negative 8x squared, which becomes a positive x squared.
Oh, okay.
So just take this slow motion. Just take this 2x to the fourth minus x cubed plus 9x squared and subtract it with 2x to the fourth plus 8x squared. And I guarantee you that you'll get this result.
Okay.
Okay?
Okay. All right, thanks.
Yeah. Thank you for the question. So again, this division process, right, is exactly the same process that we used to divide 17 and 3. The only difference now is that we have to probably repeat the process. We have to iterate the process due to the fact that now we're not dealing with just numbers, we're dealing with polynomials. So then that changes the nature of the process a bit, but essentially it's the same steps. Okay, and then once we have that, now we can write our division algorithm versions, right? Again, division algorithm version number 1 is P of x equals D of x times Q of x plus R of x. So this is really right saying 2x to the fourth minus x cubed plus 9x squared. That can be written as x squared plus 4 multiplied by 2x squared minus x plus 1 plus 4x minus 4. And again, this here is the R of x. This here is the Q of x. This here is the D of x. And this here is the P of x. Okay? So, boom. That's what we have for our first version for the division algorithm. And now for the second, we just have to rewrite this slightly different. We're going to write this as 2x to the fourth minus x cubed plus 9x squared. I'm going to divide this by my divisor, x squared plus 4. Set it equal to 2x squared minus x plus 1 plus 4x minus 4 divided by my divisor, x squared plus 4. And this is going to be the second version. Again, this here is my quotient. This here is my divisor. This here is my remainder. This is my divisor, and this is my dividend. Okay? So we should be able to express our division of polynomials either in the first version for the division algorithm or the second version. Okay. Any questions about this? For the last part, isn't it 1x squared plus 4? Wait, which part? The remainder part? Isn't the remainder 4x minus 4? And the divisor here is x squared plus 4. So that's why this portion here is x squared plus 4. Is that what you're referring to, Judy? The remainder here is 4x minus 4. Like this part right here, this part, negative x squared plus 4. Are you talking about this portion right here? You're talking about like this right here? Oh, so let's go back, okay? So this step here results in what? And results in having x squared plus 4x, correct? And then we ask ourselves, what multiplies to x squared to give me x squared? Well, it's only 1, right? 1 times x squared gives me x squared. So I multiply 1 to this whole divisor, and we get, what do we get? We get x squared plus 4. So let's take this slow motion. X squared plus 4x, right? I'm subtracting this with what? X squared plus 4. But how do you combine this? You get x squared plus 4x minus x squared minus 4. So the minus x squared, see you later, goes away. But what's left? 4x minus 4. You can't combine those terms because they're different. They're different terms, unlike terms. So the remainder is 4x minus 4. There is no x squared term. Okay. So yes, guys, please be very careful and very perceptive. And it's very easy to make little mistakes here and there along this process. You have to be very mindful for the fact that every single time that you multiply the divisor with the term that you get on top, the signs of those terms that as a result will flip when you subtract them. And when you combine them, you're able to eliminate the first term. So please be mindful of that. So that's why I put these in different colors, so you can see that the signs do change when you subtract. And again, if you don't remember, you have to understand subtracting polynomials. What does it entail to subtract polynomials? Well, it's the second polynomial that always has its sign flipped for every term. So you have to remember that. Okay, so now you're like, okay, we got that, we understand that. All right, so we're gonna do it one more time, guys, and then I'll show you something different. So what happens when my polynomial is x to the 4th plus 2x cubed minus 10x, and I'm going to divide this by the divisor, which is x minus 3. So I'm going to repeat the same process again. And I'm going to add that placeholder, 0x squared minus 10x, because it's in between here. It's lost in between the terms. And I'm going to continue with the polynomial long division, right? So I'm going to ask myself what multiplies to x to give me x to the 4th, and it's x cubed. And then I'm going to repeat x cubed times x is x to the 4th. X cubed times negative 3 is negative 3x cubed. Then what am I going to do? Subtract from the above, right? Subtract. But when I subtract again, like I've just mentioned, I distribute that negative sign into that second polynomial. So then this result becomes what? This becomes a minus. This becomes a plus. And now what happens? These cancel. See you later. Then I get 2x cubed plus 3x cubed is what? 5x cubed. And then if you want, you can bring down that 0x squared. Sorry, this is cubed. I ask myself the same question again. X multiplies to 5x cubed. What do I need to do so? I need to add by 5x squared. Then I multiply, I get 5x cubed. Then this becomes minus 15x squared. Then what happens? Subtract, right? I subtract. When I subtract, though, I need to distribute that negative sign. And this becomes what? Minus plus. Now, these terms here cancel. 0x squared plus 15x squared is 15x squared. Bring down the negative 10x. Ask myself again, what multiplies the x to give me 15x squared? Well, it's actually plus 15x. Do the same thing again. Multiply 15x with x, you get 15x squared, which is what I started with. 15x minus 3 is what? Minus 45x. What am I going to do after this? Subtract. Subtract by the negative, subtract the polynomial. I need to distribute that negative sign. And what am I going to do now? This becomes a minus. This becomes a plus. The 15x squareds cancel. Minus 10x plus 45x is 35x. Still, the degree is the same. Multiply x to what to give me 35x? You add by 35. Then you get you get 35x minus what? Minus 105. Again, you're going to be subtracting this, right? Distribute that negative sign. And when you distribute that negative sign, you switch the signs of the second polynomial. So this becomes a plus, this becomes a minus. 35x minus 35x is no more x. And what do I get at the end? 105. And then you're like, wow, that's a lot. That took a long time. And I'm able to spot what my p of x is, my q of x. This is my p of x. This is my r of x. And this is my d of x. So I've repeated polynomial long division to find a quotient and a remainder. So is this clear to everybody here? Okay. So what we're gonna do now is, maybe some have heard of this already, but I'm gonna introduce to you another way to divide polynomials that does not entail doing this long step or procedure. As it's in the name, right? It's long division. So what we're gonna learn is something that's called synthetic division, which is, as you will see, much quicker than doing this. Now, synthetic division can only be applied, okay? So we're gonna apply a new way, okay? So we're gonna divide polynomials by synthetic division. The only requisite, so this is a requirement. The only requirement that's needed for this is that the divisor, d of x, has to be in the form x minus a, where a is a constant. That is the only requirement. Other than everything being polynomials, of course. But the requirement is that d of x is x minus a number, or x plus a number. So for example, here my divisor is x minus a number. In the other examples, such as this one here, synthetic division is not applicable. The one here, you can finagle it, but still there's a 2 in front. It has to be x minus a number or x plus a number. That's the only time that synthetic division is going to be applicable. So it is going to be applicable, and look what we have here. We have the same polynomial. Now, how does this work? Well, the way it works is we look at the coefficients of my dividend. So I'm going to write the coefficients. The coefficient is what? 1. That's x to the 4th. Then we got 2, x cubed. Then we got minus 10, x. And then do we have a constant? No. But I have to include that constant, which is 0. And so, you know, some people do, they have, I think your textbook has a certain way. There's like 2 ways to write down the synthetic division to set it up. And it looks like they all have this kind of, it's not such a big deal as to how you do it, but I'm gonna do it this way. So there's a number that you put on the left of this. Actually, let's see here. Okay, so again, the first row of numbers here are the coefficients of p of x. Okay, now what's going to be placed on the outside of this, to the left, is going to be that constant. So my constant here, my a value here is 3. So I'm going to put 3 here. So what is 3 again? 3 represents the a value, quote unquote. Now, how do we proceed with this synthetic division? So first is I'm going to bring down the first coefficient, the 1. Then I'm going to multiply 3 and 1. What do I get when I get 3 and 1? 3 times 1, I get what? I get 3. And what am I going to do now with these numbers? As the numbers that are in the same column, so you can think of these as columns, I'm going to add them. 2 plus 3 is 5. Then I want to repeat the same step. 3 times 5 is what? 15. And then I'm going to combine. Negative 10 with 15 is? Wait, did we do the same one? Minus 10. Oh, I missed something, guys. I missed it. You see this? You see this? No, it shouldn't be negative 3. 3 is correct. A is 3. X minus A. So A is 3. But there's something that I myself made a tiny little boo-boo. Good thing I caught it. I caught it. That's right, Chen. I completely just disregarded that minus the x squared term. So actually there should be another 0. Do you guys see that? So do you guys see that this is the coefficient for x to the 4th? This is the coefficient for x cubed. This is the coefficient for x squared. This is the coefficient for x. This is for the coefficient for the constant. Remember what we've mentioned about polynomials? We always write them in descending order with respect to their powers. So this is even more important. That 0 is even more important for the synthetic division to really work correctly. So then again, what do I do with the 3? I multiply with the 5 and I get what? I get 15. Then what do I do with the 0 and the 5? I add. So it's multiply, add, multiply, add, multiply, add. So 0 plus 15 is 15. Then what do I do with the 3 and the 15? I multiply. 3 times 15 is 45. Then what do I do with the minus 10 and the 45? I add. What do I get? I get 35. Then I do the same thing again. 3 and 35 is what? 105. Do you guys see what's happening? And then 0 plus 105 is what? I'm gonna put the box here. This is 105. What does 105 represent? Represents the remainder. Isn't that exactly what I got for the remainder? I did. 105, that checks out. And then what do these numbers represent? Do you guys see that? 1, 5, 15, 35. What do I get here? X cubed plus 5x squared plus 15x plus 35. What are these? These are the coefficients of the quotient. Do you guys see that? And for the synthetic division, the quotient, the degree of the quotient is the degree of the dividend minus 1. It's always 1 less. So this 1 corresponds to what? X cubed. This 5, x squared. X constant. So do you guys see how, look how short, look how short the synthetic division process is compared to the long division process. I hope you guys appreciate now how quickly we can apply synthetic division. We really just have to do what? Bring down, multiply, add. Bring down, multiply, add, multiply, add, multiply, add. The only thing you have to do now is be mindful of the coefficients when you start out with, and be mindful of the coefficients at the end, with the last number always being the remainder. The last number that you get will always be the remainder.
I'm sorry, Professor. Where did that a value come from again?
It came from the fact that I said in the beginning, the divisor must be of the form x minus a number. So in this problem, the divisor is x minus a number, and that number is 3. That's where the a value came from.
Okay.
So that a value is extremely important to identify.
So if the a value, if it was x plus 3, would the a value be negative 3?
Perfection. Yes.
Okay.
Yes. That's right. That's right. So you'll see that, I believe, in the next one. Yep. Okay, so let's do this real quick. Let's do this real quick. So we already know this, how this ends, right? P of x, we know P of x is what? Is x to the 4th plus 2x cubed minus 10x. We know the divisor is x minus 3. We know the quotient is x cubed plus 5x plus 15x squared, 5x squared plus 35, and we know the remainder is 105. Once we have that, we can write this as x to the 4th plus 2x cubed minus 10x equals x minus 3 multiplied by x cubed plus 5x squared plus 15x plus 35 plus 105. This is the first version of the division algorithm. And the second version is what? It's x to the 4th plus 2x cubed minus 10x divided by x minus 3. That's equal to x cubed plus 5x squared plus 15x plus 35 plus 105 divided by x minus 3. Okay. Do we have an understanding now of how much more efficient? Do we disregard x to the 4th for what? Are you talking about for the quotient? Yeah. Like I said here, the degree of the quotient, when you have this kind of version of a polynomial division where the divisor is x minus 3, in a way you could think that the degree of the original polynomial that you're dividing, it's always going to be cut by 1 when you divide in this manner. If you notice in the other ones as well, the quotient is much less, right? When you divide this quotient 4 with 2, you get degree 2. And then when you have this one here, polynomial, the degree was 3, the divisor, the degree was 1, and what's the result? 2. So yes, in particular, when we speak about dividing by polynomials like this, so this is degree 4, this is degree 1, the quotient will always be 1 less, degree 3. Okay, so we'll see that in the next one here. So what's the next one here? What are the coefficients of P of X? Well, we start with x cubed, right? So see here, we can write this as x cubed, x squared, x, and constant. So then what's the coefficient? 1, 0, -8, 2. What's my a value? My a value here would be what? -3. And this -3 is going to be placed outside. I'm going to put like this little rectangular box here. And again, this here, the number at the end will represent my remainder. So I already know how this is going to end. All I have to do now, and the numbers that I get here are the coefficients of the quotient. And the first step I do is bring down the 1. That's the easiest part. 1, okay, I got it. Then what do I do? -3 times 1 is -3. 0 plus -3 is -3. -3 times -3 is +9. -8 plus 9 becomes +1. -3 times 1 is -3. 2 plus -3 is 1. That's how quickly it is. That's it. So then what's P of X? Well, obviously it's x cubed minus 8x plus 2. D of X is x plus 3. The quotient is what? So remember, the quotient is always a degree less than the dividend. So this is going to be x squared, x constant. So it's going to be x squared minus 3x plus 1. And what's the remainder? That's 1. Righty? So what's the division algorithm part 1 say? This is
-1.
say that again. -1. You're
Yeah.
right. You're right. You're right. X cubed minus 8x plus 2 equals x plus 3 multiplied by x squared minus 3x plus 1 minus 1. Thank you for that. That's right. It is a -1. So that's the first. Yeah, 2 minus 3 is -1, guys. Sometimes even that becomes so difficult, right, to do. 2 minus 3 is -1, not +1. So that's the first version of my division algorithm. And then the second one is what? X cubed minus 8x plus 2. You divide this by x plus 3. And the result is x squared minus 3x plus 1 minus 1 over x plus 3. And that's the other way. Any questions about synthetic division? It's much more sleek, right? It's a little like much more efficient, I would say, at dividing polynomials than the long way. All right, so I think there's one more example of this one. Yep, there's one more. And we can do this also really quick. Now look what we have. We have x to the fourth. So the highest power here is x to the fourth. Then we go down, right? X cubed, x squared, x, and then the constant. The a value here is what? What's the a value? The a value here is -2. So I got -2 placed outside. Then I want to write the coefficients of my dividend, which are what? So first one is x to the fourth is 1. There's no x cubed, so what do we put? 0. There's no x squared, so what do we put? 0. There's no x value, so what do we put? 0. The constant is -16, and that last number here will be my remainder. And these are the coefficients of my divisor, which start with x cubed, then x squared, then x, then the constant. This is my quotient. And what's the first step? Bring down the 1. Negative 2 times 1 is negative 2. Add, this becomes negative 2. Negative 2 times negative 2 is positive 4. 0 plus 4 is 4. Negative 2 times 4 is negative 8. 0 plus negative 8 is 16. Sorry, I'm already getting ahead of myself. It's minus 8. Negative 2 times negative 8 is positive 16. Negative 16 times 16 is 0. You can have a remainder of 0. That's good. 0, what's the coefficients? It's x cubed minus 2x squared plus 4x minus 8. What's my divisor? X plus 2. What's my dividend? X to the 4th minus 16. So what are we gonna eventually get at, guys? We're gonna get at the fact that you can have polynomials that evenly divide other polynomials. The same way that we have, for example, numbers that divide numbers evenly, right? The remainder is 0 in those cases. So, for example, 12 divided by 4 is 3, remainder 0. And what do we call those numbers who result in remainder zeros? We call them factors. And the same thing happens in polynomial world. We have factors. And so in this case, x plus 2 is not just a divisor, but x plus 2 is actually a factor of x to the 4th minus 16. So I can actually rewrite x to the 4th minus 16, like I'm going to do now, as a product of two factors. X to the 4th minus 16 can be rewritten as x plus 2 multiplied by x cubed minus 2x squared plus 4x minus 8. I can do this. And there's a plus 0, of course, because this is my remainder, but I don't really need that plus 0. Are you guys following this? These two guys here are factors of this. And then what is the division algorithm? X to the 4th minus 16 over x plus 2. This is the result, x cubed minus 2x squared plus 4x plus minus 8. And of course, you can say plus 0, right? You can be plus 0 over x squared plus 2, but 0 divided by anything is just 0. So I don't even need that part. Okay. Okay, so this is the synthetic division. Now, how does this help me understand polynomials a bit more? Well, on the next page, we have something that's called the factor theorem. And now this is really important, guys. So I'm going to write it, okay? So I'm going to say the following. A is a 0 of P of x. Now these arrows pointing on both directions, this is a shorthand notation for saying if and only if. This is called the bidirectional. So it means that if this is true, then the result will be true. And if you start the other way, if you say the following statement is true, then this will have to be true. It implies the other. So this goes both ways, not just one way. So if that's the case, then x minus a is a factor of P of x. And this is what's called the factor theorem. Now let's see if we can kind of tie that in with what just happened here. What can we say? By the factor theorem, what? We said that what? X plus 2, right? Didn't we say that x plus 2 is a factor of p of x, which was what? X to the fourth minus 16? That's that first, this is that first phrase here, right? That's that phrasing here. By the factor theorem, what can I say as well? Well, x plus 2 is a factor. What was my a value? Wasn't it negative 2? Then can't we also say by the factor theorem that negative 2 is a 0 of x to the fourth minus 16? Remember what a 0 meant? A 0 is the x value that when you plug into my polynomial function gives me 0. That's what it means. Or in other words, the 0 is the x-intercept. So this is extremely important, guys. The factor and the zeros come hand in hand. The factor of a polynomial and its zeros are essentially linked, inextricably linked. So if you have the 0 of a polynomial, that's the whole point. If you know what one of the zeros is, you know the factor. If you know what the factor is, you know the 0. So now look what we're going to be doing now. We're going to be finding polynomials given the zeros. So what do we know? We know that x equals negative 1 is a 0. We know that x equals 1 is a 0. And we know that x equals 3 is a 0. Right? But by the factor theorem, what do we know? If x minus 1 is a 0, then what's the factor? Isn't it x plus 1 is a factor? And then isn't this x minus 1 is a factor? And isn't this x plus, minus 3 is a factor? A factor of what? Of p of x? Of p of x? Of p of x. Do you guys see that? So if x minus 1 is a 0, x plus 1 is a factor. If x equals 1 is 0, then x minus 1 is a factor. If x equals 3 is a 0, then x minus 3 is a factor. It's equivalent to say these things. So then what would be the polynomial that I'm considering? It will be what? X plus 1 multiplied by x minus 1 multiplied by x minus 3. Again, this is in factored form. If you want to really write it out in the conventional way of highest degree to lowest degree, you would have to expand everything. And you can do that too. We can do that too. What's x minus 1 times x plus 1? Well, we know this is a difference of perfect squares, x minus 1. And now we have to multiply x squared minus 1 with x minus 3. And what do we get? We get x cubed minus 3x squared minus x plus 3. So we can also write it p of x as the following. P of x is x cubed minus 3x squared minus x plus 3. So either way, we found the polynomial. This is the factor form of the polynomial, and this is the standard form of a polynomial. Does this make sense with the factor theorem? So this is by the factor theorem. That's what the factor theorem states. The factors come from the zeros come from the factors, vice versa. And you see we want a degree 3, so this is degree 3. Okay. Now the same thing happens here, right, guys? So we can even, if you want, we can even create like a table instead, just to make things a little bit quicker. We have zeros and then we have factors. Chen, how did we get x cubed? So I did this, I guess it's not that fast. I just did the distribution process really quickly. X cubed minus x is x cubed. X squared minus x is x cubed, right? And then x squared minus 3x is what? Minus 3x squared. And then minus x, minus 1 times x is negative x. And then negative 1 times positive, negative 3 is positive. That's what I did. I just didn't do the whole, you know. So then what are the factors? If x equals 1, if x equals negative 2, what's my factor? My corresponding factor would have to be x plus 2. Then if x equals 0, what's going to be my factor? It's going to be just x, because x plus 0 is just x, or x minus 0 is x. And then what if x equals 2, what's my factor? X minus 2. Do you guys see that? And x equals 4, finally? X minus 4. So then what's going to be my polynomial? My polynomial is made up of all the factors. That's what the factors do. They give me the polynomial. So then I can multiply everything out. X times x minus 2 times x plus 2 times x minus 4. That's my polynomial. And I can leave it this way because this is a factored form. If you want to write it in the longer way, then you can multiply everything out. But I'm just going to leave it in factored form due to time. Does everybody see that? Does this make sense so far, guys? The whole zeros, factors, factors, zeros, zeros, factors. Okay, and then now we're on to the last thing, guys. The last thing. The last thing now is given a graph, can I do the same thing? So given the graph, so what do we know about this graph here? This is a polynomial. What do we know? Or what can we highlight? We can highlight the zeros. What are the zeros? Or it's already written here. What are the zeros? Well, x equals what? Negative 1. X equals what? 1. And x equals what? 2. So if x equals negative 1, x equals 1, and x equals 2 are the zeros, then what are the factors? X plus 1 is a factor. X minus 1 is a factor. X minus 2 is a factor. Do you guys see that? What's the y-intercept? The y-intercept is right here at negative 2. So at negative 2. Okay, so this is just a little bit more steps here because we want to find p of x, right? P of x is made up of all the factors. So this is x plus 1, x minus 1, x minus 2, correct? The only problem now is that there's some value, the leading coefficient, I don't know. Why don't I know this? I don't know the leading coefficient because of my y-intercept. What do I know? I know that my y-intercept is negative 2. So that means that when I plug in 0 into my function, what should I get? I should get back negative 2. So 0 plus 1 is 1. 0 minus 1 is negative 1. And I get negative 2. So I get what? This whole thing reduces to what? 2. So I get 2a equals negative 2. So what does a have to equal? Negative 1. So guys, this is a key step. The key step here is finding the leading coefficient. That's the only extra step that I need to do here. So the leading coefficient is what? This equals negative 1. Now this a here, guys, is not the same a as the one that we've talked about before. It's not the same a value. These a values here, this refers to the zeros, okay? And this here is the coefficient. So you know what I'm going to do? I'm just going to write this as c, so there's no confusion. This is a c value, c value, c value, c value. Then I can say this is c value equals negative 1. And so what does p of x finally equal? It equals this. It's negative 1 multiplied by x plus 1, x minus 1, x minus 2. So that's it. If I graph this, if I put this in my graphing calculator or any graphing device, if I put this in, I get exactly this polynomial. Exactly. Okay. Now the next one, we can do this really quickly. The next one here, we only have how many? We have x equals negative 2, x equals negative 1, and x equals 1, right? These are my zeros. So then my factors are what? X plus 2, x plus 1, and x equals x minus 1. These are my different factors. The difference still, guys, is that this here, you see how it doesn't go through like the other x-intercepts? So this has a multiplicity of what? An even multiplicity. In this case, it's going to be a multiplicity of 2. So that's important. So this is really a what? A 2 here, right? For x equals 1. So there should be a 2 for the factor. It repeats twice. And what's the y-intercept? The y-intercept here is 4. So this equals 4. So then this would be what? So p of x, to find the leading coefficient, you do what? C multiplied by x plus 2, multiplied by x plus 1, x minus 1 squared. I plug in 0. And I get c times 0 plus 2, 0 plus 1, 0 minus 1 squared. This has to give me 4. So then what do I get? I get 2 times 1 times negative 1 squared. I get 2c equals 4. So c has to equal 2. The multiplicities are R tensilla. Yeah, these are multiplicities that are odd. These are 1. The point is that this has a degree of 4. So these have to add up to 4. So 2 plus 1 plus 1, they add up to 4. Okay? And so what's the leading coefficient? The leading coefficient is 2. So then what's the result? It's 2 multiplied by x plus 2, multiplied by x minus 1, x minus 1 squared. So again, guys, it's important to know what the degree is of the polynomial. So for example, if someone says, find a degree of this being 6, then I would have to make this multiplicity of 4 so that it works out. It works out with the rest of the terms to add up to the degree. All right. Okay, so we're done with this. For p of x, there's an error. What's the error? X plus 2, x plus... Oh, yeah, there's a plus 1. I think that's what you meant, right? There should be a plus instead of a minus. Right? And so Chen, where did I get the 2c and 4 from? I'm finding the leading coefficient. To find the leading coefficient, right, I need to use the y-intercept. What is the y-intercept? 4. What does that mean? The y-intercept of 4 means that the x value is 0. So that's why I plug in 0 for my x value, and my y value has to equal 4 because that's the y-intercept. But I already know that the structure of my polynomial has this form. So I plug in 0 into all of these, and the result when I do this is what? I get 2. This is 2. But I have this c in front that I'm looking for. So I know that 2c equals 4 and c equals 2. That's why. And then all I have to do is plug in that 2, and then I write that. I write it as my polynomial. That's my polynomial. My polynomial has these factors because of the zeros. This factor here has a multiplicity of 2 because it doesn't go through, it bounces back. And then if you notice, this does add up. The coefficients, if you look at the leading coefficient, the degree would be 4, which is exactly what I want, degree of 4. And then I have the leading coefficient of 2, and this will give me the y-intercept of 4. Okay, guys? The 2c, no, it's not because the multiplicity is 2. The 2c is because, I explained it. It's because I have the factors, correct? I got the 1 factor, 2 factor, 3 factor. I know that when you multiply them, I get p of x. What I'm missing is the coefficient in front of everything, the leading coefficient. But what do I know? I know that the y-intercept is 4, which means that if I plug in 0 for x, I get my y value being 4. That's why. And when I plug in 0 for x, right? When I plug in 0, 0, 0, the result of plugging in 0 and multiplying all these numbers is I get 2. This whole thing is 2 equal to 2. But what is 2 being multiplied to? To c. So 2c equals 4. And henceforth, c equals 2. It's not because of multiplicity. It's because of the polynomial, the way it's written. Okay? Yeah, you have to think about this a bit more, guys. A bit more. All right, guys. So I'm going to give you the quiz now. It's going to be on Google Classroom. It's only 2 questions, guys. It should be short. It shouldn't take too long. Only 2 questions. I'm not giving you that much. So just give me. It's going to be posted in quiz number 3. Let's see. Oh. All right. So I'm posting it right now. Please upload. See it in your Google Classroom. It's under quiz number 3. Under quizzes, quiz number 3. And it's 2 questions. So please, when you finish, upload your work on Google Classroom and you can be dismissed. You have 15 minutes for the quiz. And I'm pretty sure you would not need all of it to complete it.